Welcome to qnawire.
Hi there, so over here we're asked to draw a molecular visualization with 5 plus molecules of water and 5 plus molecules of ethyl acetate, which showcases what does it mean for something to be insoluble in water. So in this case, what this means is that we're going to have two different phases in which the water and the ethyl acetate are not going to be able to mix. On one side, we're going to have water molecules. Let's put one here. And so on and so forth. You can continue writing down different water molecules. And on the other phase, we're going to have a series of ethyl acetate molecules. We can switch the direction which we're doing the drawing. We can even invert one of them just to showcase what is going on, and so on and so forth. In the interface, we're going to have a small mixture of some water molecules and some ethyl acetate molecules. But in general, over here, they're not going to be able to mix as much. So this is called the interface in between both of the liquids that we're going to have. Now, with this information, now what we want to know is what does it going to be looking like in a separatory funnel. First of all, in order to know that, the ethyl acetate, we know that the density is of 0.902 gram per milliliter, while the density of water is going to be equal to 1 gram per milliliter. So the ethyl acetate is going to be on the upper layer on the separatory funnel. I'm going to try to draw this as accurate as possible. We have here our little key, which we can turn. Something like this. And here you're going to have the drops. So what is going to happen is that we're going to have an interface and an upper layer. On the upper side, that is going to be the organic layer. We're going to have the ethyl acetate, while on the aqueous phase, we're going to have the water molecules. That is going to be on the lower part. In addition to this, we want to know what is going to happen with Allura red, in which phase it is going to dissolve in. And in order to do that, we need to have a look at the structure. So the structure of this compound is complex, but what we can say about it is that it is a salt, it is charged, it has a bunch of polar bonds, for example, OH bonds, SO bonds. We also have SO bonds, and yeah, I think those are and oxygen CH3 carbon bonds. So all of those are going to be polar bonds that are going to increase the solubility in water. And just because of the salt and the charged part of the molecule, this is going to be highly soluble in water. So Allura red is going to appear on the aqueous phase, meaning that the water that you're going to have on your separation funnel is going to be mainly red. And with that, it would be all. Thank you very much and have a good one.